Back at it. Revenue. Eventually. There we go. Revenue, X times P. We have a quadratic. We want to know the domain of that. What would the domain of a price? No, domain, remember, is X. Right? And what's acting like X in this problem? The price. Okay? So what can the price, when we think about domain, what's our price going to be stopped at? 0, right? Is it going to include 0? Why not? We're not making any money at all. That'd be giving it away, right? We don't want to give it away. So our domain starts at 0 and then goes up to what? Does it go to infinity? Can we charge an infinite amount of money for our widgets? Not necessarily. Okay. Where would it stop? Why 1,500? Because it's our y-intercept. But that's a y value. Domain's dealing with what? X value. So the price is what when would the price create a no domain? That's the question. When does what price creates no domain? How do we find out when the price creates no domain? No. Well, how'd you get there? That's the right math, but how are you getting there? What's this equation up here? This is demand, right? When is demand at its lowest? When nobody's buying any, right? So demand would be what? When nobody's buying any? 0. So if demand is equal to 0, then we'll find a price that put us out of the market. So we set demand equal to 0 and solve that. And Cameron was right. It ends up being negative 1,500 divided by negative 30, which gets us 50 as the price that puts us out of the market. So our domain for this one is from 0 to 50 for the price, because you can price yourself out of the market. Okay, and then here we're getting that. So that domain there is from 0 to $50.
I'm sorry, how was it 50?
You set your demand equal to 0 and solve.
So it'd be 1,500 minus 30.
It'd be 1,500 minus 30p equals 0. And then you solve it.
Okay.
And subtract 1,500, divide by negative 30. That gets the price by itself, and it's 50.
I thought you literally meant 1,500 minus 30.
No. Take your demand, set it equal to 0. That's going to find you the price that cuts it off. They used an inequality to do it. It's the same. It gets you the same result. Just you got to know, hey, anything less than that, I can charge and still get something happening there. All right. Part C said, what price should be used to maximize revenue? Okay, if we're going to maximize revenue, what X value or price value is the maximum at? How do we find that? How do we find the X value of a vertex? Negative B over 2A. So negative B here's our quadratic right here. Negative 30p squared plus 50p or 1,500p. Okay, that's our quadratic. To find the price that's at the maximum revenue, we take negative 1,500 divided by 2 times negative 30. $25. When we charge $25 for our widgets or whatever product we've made, that's where our maximum revenue is going to come from. Okay, so that's the X value of the vertex, because it said maximize. What price maximizes it? $25 is the price that maximizes. Part D says if the price this price is charged, what's the maximum revenue? Remember that our quadratic is the revenue quadratic. So if this is the price, then how much revenue do we get? We plug it in, work it out. find the Y value of the vertex. That's the revenue. Okay. And we plug that in here. R of 25, plug it in, work it out. $18,750. That's how much revenue we're getting if we're charging 25 bucks per widget or whatever product we got. Okay. Definitely something that happens in marketing. You look for those things. That's part of your job. Marketing analysts make a lot of money, a lot more than teachers do. They do stuff like this. They crunch numbers and look at what price we set this at creates a higher demand, and we want to maximize revenue if we can. Okay. But you also got to figure in costs and all that stuff, which is not part of this problem. Okay. So it said maximize. We got to look at vertex. Okay. Then it says E part, same problem. We got the same equation here. We found all that stuff before. And it says how many units are sold at that price. Okay. So our price was how much? What was the maximized price? $25. If we sell that many, what's the demand? Is what they're asking there. That's what they're asking when they say how many units. The demand equation is the number of units. So we plug in 25 bucks, right? For P in the demand equation to find out how many units we're selling. Okay. Because it tells us in the problem the number X of widgets sold is given by this demand equation. It tells you this equation tells you how many are sold at a certain price. Okay, and that's just through market research. You know that's happening. It's trending toward this. So we plug in 25 for P. 750 widgets are being sold to get that at that maximized price. To maximize revenue, we're selling 750. It asks us to graph that equation. What do you do? Graph it with what? Calculator. Absolutely. So let's graph it with our calculator. I got a stat plot on. Let me turn that thing off. Off. Like this. Okay, so negative 30. And instead of P, use X squared plus 1500 X. All right. I'm going to hit graph. I'm going to hit zoom. Hit zoom. And then I'm going to use zoom 0 for zoom fit. So I get to see that parabolic shape there. And what zoom fit? Zoom 0 is what you're getting get to do there. Hit zoom 0. Getting something like that. Get your X min to 0 and your X max to no, make that like 60. Then hit graph. You see a little different view there, but you see it's a parabola. That's the main thing. Anybody else have a calculator problem? As long as you're seeing it, it's a parabola. That's the main thing. Okay. All right. If you've got a stat plot on, it may graph it, but it may make your window kind of weird. you're getting the idea that it's a parabola, right? That's the main thing here. Not necessarily anything other than just making sure it looks like a parabola. Yeah, you're okay. You're okay. If it just, as long as you see that it's a curved graph, it's a parabola. You should know that already. But anyway, we're looking at that graph, and then they want us to. What's the next thing? What price widgets should we charge to collect at least 12,000 in revenue? Okay, 12,000 in revenue is what kind of value? An X or a Y value? A Y value. So we need to find what X value gives us $12,000. Okay, how do we do that? Here's one way to do it. Let me show you this. Y equals. When Y equals 12,000, right? So that's what my red line represents, the revenue of 12,000. How many different places would there be? 2 different ones. So how do we find those 2 different ones? We work out the problem. We set the revenue equation equal to 12,000 and solve it. Using quadratic formula, factoring, whichever way you want to solve it. Quadratic formula is what I would do. That's not a big deal that it's not short. The key here is that you're going to have to do some algebra. You're going to have to set the equation equal to 12,000 and work it out. Okay, solve it. Find the exact value for the price that gets us 12,000 in revenue. Maybe that gets us the profit we need. We know we can't charge $25 for it, even though it would maximize revenue. If we charge $25 for it, it may drive down some of our customers. Maybe we need $12,000 in revenue to make ends meet this quarter or whatever. Okay, so that would be an option. So you would set that equation equal to 12,000 and solve it. And the way you do that, so here we've got that. There's the graph. Their window's a little different than theirs. They did it with that with Excel, but set that equation equal to 12,000. Set her up there. Get it equal to 0. And they're using factoring because 30 goes into all of those. And then you could factor that P plus or P minus 10 and P minus 40. You get that to work. And then you get the prices of $10 and $40 get you a $12,000 revenue out of that. This part you should know how you've already done that. That's just the algebra that goes with that. So the big part is the word problems, and what you need to go from there. Let's look at the next thing. Let's look at maximizing area of an enclosed by a fence. Okay. Farmer's got 1,600 yards of fence to enclose a rectangular field. So they've drawn a rectangular field. If there's not a picture with the word problem, start by drawing a picture of what they describe. If they say rectangular field, draw a rectangle. That gives you something to work with, okay? And then what are the dimensions of the rectangle that closes in the most area? Okay, so we want the biggest area of a rectangular field. Okay, what do we know about areas of rectangles? How do you find area of a rectangle? Length times width. X times W in this case, because they labeled our length X. Length times width. Okay. Now, what do we know about the total amount of fence? So that would mean the perimeter of the thing is 1,600. No matter how wide or tall it is, the perimeter is 1,600. Okay. That would be 2 times the length plus 2 times the width equals 1,600. That's the perimeter formula. That's where that comes from. Okay, perimeter of a rectangle. Okay. Now, to maximize this, we need to use just one variable, either X or W. It does not matter which one you pick to use. I'm going to use X, I believe. So I need to solve this equation for W so that I can replace W with stuff that has an X in it. Okay? So if I solve that for W, I would subtract 2X and then divide by 2 to get W equals 800 minus X. Subtract 2X here, divide by 2, gets W by itself. That's going to allow us to replace W with something that's X. Okay? Because we have trouble solving equations that have 2 variables. One variable, we got a lot of tools to do that with. Okay? So that's our width now. So that would mean our area equation becomes X times W, 800 minus X. Length times width. Multiply that out, it becomes a what? Quadratic. We want to find the dimensions that enclose the most area. Most implies we're looking for the what? Maximum. Okay, so what are we looking for out of this equation? The maximum. The vertex, right? So negative b over 2a gets you the x value, or the length in our case. And then we could then find the width by taking 800 minus whatever x is. Okay, so negative b over 2a. Negative 800 over 2 times negative 1 be positive 400. So our length is 400. Our width would be how much? Turns out to be 400. Okay. So those are the dimensions of the field that maximizes the area. Say 400 by 400 field. Using vertex and a quadratic. That really is what it is. Okay. All right. It would make it a square. That's absolutely correct. Yeah. All right. Next thing, projectile motion. Projectile motion, they're going to give you an equation already in quadratic form, which is a good thing. You don't have to build anything. It's a lot easier to me. Okay. They say projectiles fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. In physics, this is established that the height of the projectile over the water can be given by this equation. So they give you this equation. They plugged in some stuff in there, project the initial velocity here. This 32, negative 32 is the gravity, 32 feet per second. I don't know if you ever talked about that in chemistry or biology or something like that, but that's where that's coming from. The 500, where did it come from? The height it was above water, right? That's where we started. So like it'd be like if I were throwing a ball, it would be starting at 5'6" or something like that. That, and it follows that motion. X is the horizontal distance of the projectile from the base of the cliff. H of X is the height it is above the water. Okay, so that's what this equation finds. It says find the maximum height of the projectile. How high did it go? What is the maximum height going to be in? The what of the parabola? The vertex of the parabola. The y value of the vertex of the parabola. Okay. Negative b over 2a. A is kind of wonky here. It's a big fraction there, but it's negative b. B is 1, so that's negative 1 divided by 2 times this ugly fraction. Do the fraction, get it as a decimal, and work with it from there. Okay? And then you do that, and we get 5,000 divided by 2. 2,500 is the maximum height when they shoot this projectile, whatever it is, missile, could be a cannon, could be, pumpkins. Remember what pumpkin chunky? They do this. Okay, so that's the maximum distance away from zero or from the cliff. That's not the maximum height, right? Maximum height. Plug that in, work it out. The maximum height is at 1750. By plugging it in and finding the y value of the vertex. Okay, you've got to pay attention to these word problems. What's x and what's y, and what are they asking for? Are they asking for distance away from the? How far did it travel? Distance away from you, or how far did it travel up and down? You've got to pay attention to those things with this stuff. Okay, we will finish this up in the morning. Okay, you guys have a good day.